Hello dear students, welcome to another lecture of engineering mechanics. This is lecture number 10 and in today's lecture we are going to solve problems related to dry friction, and we are going to only consider problems based on statics, because I have already told you yesterday the kinetic part of the friction that we are going to cover in kinetics. Now right now we are only studying statics, so we will deal with problems of statics based on dry friction. Now before we get into today's lecture, before we start solving problems, let's recap whatever we have covered in the last lecture. So in the last lecture we saw the concept of friction. Good evening, good evening, good evening. What is friction? It is a force that resists the relative motion between two surfaces, and I told you that there is dry friction and then there is wet friction. What do we mean by dry friction? If there is no lubrication between the surfaces, then it will be called as dry friction, and if there is a lubricating oil, lubricating fluid between the surfaces, then it is wet friction. The concepts of wet friction is dealt in machine design, because there you have to also apply the concept of fluid mechanics, okay? But here we are only considering dry friction, and we saw the mechanism of dry friction given by Coulomb. We saw this graph yesterday that if you apply force on a body, initially the friction force acting between the surfaces is equal and opposite to the force, but as you keep on increasing the force at a particular value of the force, the friction becomes maximum, right? Then it drops and becomes constant. Now what is the maximum value of friction? The maximum value of friction is mu s into n, called as what? Limiting friction, right? Mu s into n, which is called as limiting friction. And what is the kinetic friction, which is constant? It is mu k into n. Mu s is known as the static coefficient of friction and mu k is known as the kinetic coefficient of friction. Both these coefficient of frictions are dependent on material, types of material, the texture of material, and mu k is slightly less than mu s. Okay, we have seen this concept. Then we saw what is friction angle. What is friction angle, beta? It is the angle between the resultant and the normal force, and it is given by what? Tan inverse of mu. If you put mu s, then it is the static friction angle. If you put mu k, then it is kinetic friction angle. And then we saw angle of repose, the angle at which the body starts falling from an inclined surface, and its value is how much? It is equal to the friction angle. Okay, so we have seen all these concepts yesterday and I gave you a problem to solve. I hope you have solved this problem. This was an MSQ question. A box of weight 100 Newton is kept on rough horizontal plane. Coefficient of static and kinetic friction are given 0.4, 0.3. If a force P is applied, which one or more of the following statement is or are correct? One by one, let's see. If P is 20 Newton, friction force is 20 Newton. Okay, you are getting A, B and D. Let's see whether it is correct or not. If P is 20 Newton, friction force is 20 Newton. So first we need to know the limiting value of the friction. Why? Because if the force is less than limiting friction, then it will be static, and if it is more than limiting friction, then it will be kinetic. So we need to know whether it is static or moving. According to that, we will apply the equilibrium equations, right? So if I draw the free body diagram of this box, I see that the weight of this box is 100 Newton. This is the weight of the box, 100 Newton. Now there will be a normal force from the surface, right? Let me call this normal force N1. because we are using N for Newton, na? So let me put it N1, and we are applying a force P from here. So there will be a friction force here. Now what people make mistake is they immediately put friction force equal to mu into N. Beta, that is not always the friction force, right? If you look at this graph, friction force is not always mu into N. Maximum static friction force is mu s into N, and kinetic friction force is mu k into N. But it is not always mu into N, right? So now what we are going to do is we are going to find the limiting friction. Limiting friction means F maximum, which is mu s into N. And what will be, sorry, N1. And what is the value of N1 here? N1 is 100 Newton, right? Because in Y direction the box is not moving. So N1 is equal to 100 Newton. So mu s is 0.4, N1 is 100. So F maximum is 40 Newton, which means up to 40 Newton this box is not going to move. This box will move after you apply P greater than 40 Newton. Now in the first case we are applying only 20 Newton. In the first case, if P is equal to 20 Newton, then beta F will also be equal to 20 Newton. Why? Look at this graph, na? If you are applying P equal to only this much, this is 40 Newton, right? F maximum is 40 Newton, but you are applying only 20 Newton, then F will also be 20 Newton because the box is static, right? So from summation of Fx equals to 0, P will be equal to F. So F will be equal to 20 Newton, right? Next question is minimum force required to move the box. So minimum force to move the box will be equal to how much? 40 Newton. Until and unless you apply a force more than 40 Newton, the box is not going to move. So minimum force required to move the box is 40 Newton. So this statement is correct, this statement is correct. Now next statement, if P is 50 Newton, then what will be the friction force? If P is 50 Newton, then F will be mu k into N1. Because after 40 Newton, the block will start moving. And when the block will start moving, your friction force will be the kinetic friction force, mu k into N1. What is mu k? 0.3. N1, 100. So it will be 30 Newton, not 50 Newton. So this statement is wrong. Last statement, angle of static friction is 21.8 degree. So phi will be equal to tan inverse of mu s, means tan inverse of 0.4. So if you do tan inverse 0.4, you are getting you're getting 21.801. So the angle of static friction is 21.8 degree. So this is also correct. So very good, beta. You have the correct answers A, B and D. Now let's move on to today's lecture. So we will be solving lot more questions based on dry friction, and we will also see the concept of tipping. Okay. So let's start with the first question for today. This is an MCQ question, only one possible answer. The crate has a weight of 350 Newton. This is a crate which has a weight of 350 Newton and coefficient of static and kinetic friction are 0.3 and 0.2. if theta is 45 degree and P is 100 Newton, friction force on the floor is. So we have a crate which is subjected to a force P at an angle theta. If P is 100 Newton and theta is 45 degree, what will be the friction force on the floor? Static and kinetic coefficient of frictions are mentioned in the question. Now you need to first find the limiting friction. Why do we need to find limiting friction, sir? In the last question also you did the same. Why you are calculating this thing first? Because we need to know whether the box is moving or not moving, right? And that will depend upon this value. Okay, so let's find out the limiting friction here. So we draw the free body diagram. Okay, so this is the P which is acting at 45 degree. Okay, this is weight of the crate, which is how much? 350 Newton. This is 100 Newton. Now there will be a normal force between the crate and the floor. Let me call this normal force N1, and there will be a friction force opposite to the motion. So we are trying to move this crate towards right. So friction force will be towards left. Right now I don't know how much is the friction force, so I will just put it F. Don't make the mistake of writing it mu into N, because you don't know what is the condition, right? There is no condition mentioned that the crate is just about to move or something like that. So we have just applied F. Now we need to find F. How we will find? By applying equilibrium equation. How you can apply equilibrium equation? First you need to find out whether this is in equilibrium or not, right? So if I apply 100 Newton, whether this block will move or not, that I need to find first. Okay. Now resolve this P into two components. So this is 100 cos 45. This is 100 sin 45. Okay. So I will first find the value of N1. Okay. Now in y direction I can apply equilibrium equation. Arey, sir, you just told me that we don't know whether the block is in equilibrium or not. Then how you are applying this? Beta, this block will always remain in equilibrium in y direction. In y direction, are you trying to move it? No, you are trying to move it in x direction. If this block moves, it will move in x direction. In y direction, it is in equilibrium, right? So that is why we can apply this equilibrium equation, because we already know it is not moving in y direction. Okay, but we can't apply summation of fx equals to 0 right now, because we don't know whether it is moving in x or not. I hope it is clear. So in y direction, what will be the equilibrium equation? It will be N1 plus 100 sin 45 minus 350 equal to 0. So from here you will get the value of N1. 350 minus 100 sin 45. I am getting 279.29 Newton. So this is the value of normal reaction N1. Now we will find out the limiting friction. What is limiting friction, beta? Limiting friction is F maximum, which is mu s into N1. What is the value of mu s? 0.3. What is the value of N1? 279.29. So F maximum is 0.3 times of N1 means 83.78 Newton. Okay. So this is the maximum friction force. Now 100 cos 45, the force which is trying to move this block is how much? 100 cos 45 means force trying to move the crate. This is crate, na? Is 100 cos 45, which is how much? 70.71. So beta, this is less than F maximum, right? It is less than F maximum. It means in order to move this block, we need to apply 83.78 Newton of force. But we are only applying 70.71 Newton. It means the block is not moving. Hence, the crate is in equilibrium. So summation of Fx will be equal to 0 and F will be equal to P cos 45 means 70.71 Newton. I hope it is clear to you. I hope it is clear to you. First we find out whether the block is moving or not. So we found out that the maximum friction force, the minimum force required to move the block is this much. This is the maximum friction force. So minimum force you need to apply on the block to move it is this much. But we are only applying this much. So it is not moving. If it is not moving, then we can apply equilibrium equation. Summation of Fx equals to 0, which will give me F equal to 100 cos 45 means 70.71 Newton. So B is the correct answer, 70.7 Newton. I hope this question is clear. So this was an MCQ question based on finding the friction force. Very simple question. Let's move on to the next question, and this is another very interesting question. Okay, the uniform dresser, this is a dresser. Okay, here there are different drawers, you put your clothes like that. So this is a dresser. The uniform dresser, why they are saying uniform dresser? Because the weight is uniformly distributed, so you can apply the weight at the center. Okay, the uniform dresser has a weight of 500 Newton and rests on a tile floor for which coefficient of friction is 0.3. Which coefficient of friction, static or kinetic? That you will understand. If the man pushes it in the direction theta equal to 30 degree, smallest magnitude of force F needed to move the dresser is. So here beta they have given us a condition. What is the condition? Understand. They are saying we need to apply a force F just needed to move this dresser. We need to only apply that much force which will just move this dresser. That's it. Just move. It means we need to assume that the dresser is on the verge of motion. We need to assume that the dresser is on the verge of motion. So by assuming that, you draw the free body diagram of the dresser. Okay, assume that the dresser is just about to move. Okay, so in that case, friction force acting on the dresser will be equal to the limiting friction, which is mu s into n. So understand, whenever they say find the minimum force required to move the body, you will assume that body is on the verge of motion and the friction force will become equal to limiting friction. In the last question, this statement was not written that the crate is just about to move or find the force required to just move the crate. It was not mentioned. That is why here we could not assume friction force equal to mu s into n, but here they have mentioned it. So draw the free body diagram of the dresser. The weight of the dresser is 500 Newton. We are applying a force F at theta equal to 30 degree like this. There will be a normal force from the bottom and we are trying to move this dresser towards right side. By applying a force like this, we are trying to move it towards right. So friction force will be towards left. So weight of the dresser is 100. Okay, sorry. Weight of the dresser is 500 Newton. This normal force is N1. This is F and limiting friction will be mu s into n. Now they have not mentioned whether it is static coefficient of friction or kinetic coefficient of friction. I will automatically assume that it is static coefficient of friction, 0.3 N1. Now this is the free body diagram of the dresser. How many unknown do you see here? You see two unknowns, F and N1. So by applying equilibrium equations, you can find F, you can find N1. How many equilibrium equations do we have? We have two equilibrium equations. Summation of Fx equals to 0, summation of Fy equal to 0. You will say that, sir, we can also take the moment. Do you see the distances? Do you see that? What is the distance of this force, that force? No. So you can't use the moment equation here, okay? Now, by applying equilibrium equation, summation of Fx and summation of Fy, we can solve this problem, right? But I will give you a better way to solve this problem. You can use this equation, summation of Fx equals to 0, summation of Fy equal to 0. But I will give you a better solution, okay? First, let me write summation of Fx and summation of Fy equations, okay? So that if you are using this method, you will be able to solve it. So from summation of Fx equals to 0, what you are going to get is, this is 0.3 N1, this is F. You will resolve F into two components. So this will be F sin 30 and this will be F cos 30. Okay. So summation of Fx equals to 0 will give you F cos 30 minus 0.3 N1 equal to 0. Okay. And summation of Fy equal to 0 will give you N1 minus F sin 30 minus 500 equal to 0. So you have these two equations, you have two unknowns. By solving these two equations, you can find the value of N1 as well as F. But I will give you a better solution. What is the better solution? Instead of considering the normal and friction force separately, I want you to consider the resultant of normal and friction force. Instead of considering normal and friction force separately, I want you to consider the resultant of normal and friction force. I have told you yesterday that in some problems we replace normal and friction force with their resultant, and their resultant will be acting at an angle phi with normal force. You know the direction of normal force, so resultant will be making phi with normal force. What will be the value of phi? It will be tan inverse of mu, means tan inverse of 0.3. What is tan inverse of 0.3? It is 16.7 degree. So you know the direction of resultant. It is at 16.7 degree with vertical. So now you have only three forces, F, 500 and R. So I can use Lami's theorem here. This is 500, which is vertical. This is F, acting at 30 degree with horizontal, and this is R, acting at 16.7 degree with vertical. This is 30 degree, this is 16.7 degree. So now you can easily find the value of F, right? Apply the Lami's theorem. I can say that F divided by sine of angle between R and 500, it will be equal to how much? 180 minus 16.7 degree, right? Angle between 500 and R will be 180 minus this angle 16.7 degree, and it will be equal to 500 divided by angle between R and F, 90 plus 16.7 plus 30. What will be this total angle from here to here? 16.7, 90 and 30. So it will be sine of 16.7 plus 90 plus 30. So from here you get the value of F. Tell me what is the value of F you are getting? 500 sine 180 minus 16.7 divided by sine 90 plus 16.7 plus 30. So I am getting 209.5 Newton. 209.5 Newton. You are getting 136.7. How come? I think it will be 209.5 only. From here also you should get the same. Let me check. $209.5. Yes, my answer is correct. 209.5 Newton. Okay. The answer is 209.5 Newton. This will be the minimum force required. Acha, you gave the value of the angle. Okay, so sorry. 136.7 degrees is the angle. Okay. So 209.5 Newton is the minimum force required to push this drawer on this floor. Move the drawer on this floor. Drawer bol raha hu. Sorry, dresser. Chalo. So let's move on to the next question then. You can use this method also. You can apply summation of fx and f5 also. From here what will happen? You will get the value of n1. n1 is f cos 30 divided by 0.3, right? F cos 30 divided by 0.3. Then you put it here. So it will become f cos 30 by 0.3 minus f sin 30 equal to 500. Solve this and you will get 209.5 Newton. Okay, so from here also you can find the value, but this is more convenient because we have less equations to solve, right? Although it seems the same, right? It will take same amount of time solving this and this. Okay, chalo. Now this is a very interesting question. understand the concept behind this question. Okay, very interesting question where you will find where you will understand a very interesting concept. Let's solve this question. This is an MCQ question, not NAT. I don't know why it is written NAT. This is an MCQ question. So what is the question? Two blocks A and B of weight 100 Newton and 200 Newton respectively are kept on a rough surface as shown in figure. We have a block of 100 Newton which is resting on a block of 200 Newton which is resting on a rough floor. The maximum horizontal force P that can be applied to block A without causing the motion of either of the block is. Understand the concept of solving this question, okay? We have two blocks, block A and block B. We are applying force on block A. Now they are saying that without causing the motion of either of the blocks, how much force P you can apply. Now here the coefficient of friction between this surface and this surface is different. Here it is 0.2, here it is 0.1. Now let's understand how this question is going to be solved. Okay, see, when you apply a force P here, there are two surfaces where the friction force will be acting. There will be one friction force here and there will be one friction force here, right? There will be one friction force between A and B. There will be one friction force between B and this one. Let's suppose the friction force here is greater than the friction force here. Let's suppose friction force here is, I'm just taking a value, okay, random. Let's say it is 80 Newton and friction force here is, let's say, 40 Newton. Then what is going to happen, beta? The moment you apply 40 Newton force here, this block will start slipping, right? This block will start sliding because here the friction force is 80 Newton. So this block is not going to move because you are not applying more than 80, but you are applying more than 40. Here the friction force is 40. So this block will start moving. Do you understand what I am saying? The friction force at this surface and this surface is different. Okay. If the friction force here is more than friction force here, then block A will start moving first. This block will not move because here friction force is more. But if the friction force here is more than here, then what is going to happen, beta? Then this block will start moving from this surface. What will happen to this block? It will move with this block. There will be no sliding on this surface, right? Because friction force here is more. So there will be no sliding on this surface. There will be sliding on this surface. So both the blocks will start moving together. Do you understand the second condition? Friction force on surface number 2 is less than friction force on surface number 1. So sliding will happen on this surface first. So both the blocks will start moving together. So whether block A will move alone or block A and B will move together, that depends upon whether the friction force at surface number 1 is more or friction force on surface number 2 is more. Now do you know that right now what is the friction force on surface number 1 and friction force on surface number 2? No, you don't know. So what you are going to do is, you are going to assume there will be two cases. Case number 1, case number 1. Case number 1. Assuming impending sliding. Impending sliding means what, sir? Impending means just about to happen. Assuming impending sliding on surface 1. It means we are assuming that surface 1 is just about to slide. On surface 1, this block is just about to slide. So this block will move alone. And what will be case number 2, sir? What will be case number 2? Case number 2 will be assuming impending sliding on surface number 2. So if there is impending sliding on surface number 2, then both the blocks will start moving together. So what we are going to do is, we are going to find the value of P in both cases. Let's find the value of P in both cases. So in the case 1, if I draw the free body diagram, I am assuming impending sliding on surface number 1. Means I will draw the free body diagram of only block A. So weight of block A is 100 Newton. I am applying a force P here. There will be some normal force and there will be some friction force. Let me call this N1 and this will be mu into N1. Mu at surface number 1 is 0.2. Okay. I hope that this free body diagram is clear to you. Okay. So what we are going to do is, we are going to find the value of P in this. So summation of Fy equal to 0 will give you N1 equal to 100 Newton. Now we are assuming impending motion. So motion is not actually happening. Motion is not actually happening. So we can apply equilibrium equation in X also. So summation of Fx will be equal to 0, which will give me P equal to 0.2 N1, means P equal to 20 Newton. Okay, I got value of P 20 Newton. What does this mean? If you apply P equal to 20 Newton, slightly more than 20 Newton, block A will start moving. Okay, block A will start moving. Now, assuming impending motion on the surface number 2. So here, I will draw the FBD of block A and block B together. Okay. So weight of block A, weight of block B. There will be a normal force here and friction force here. This is P. This is 100 Newton. This is 200 Newton. Na? This will be N2. This will be 0.1 N2. Coefficient of friction at surface number 2 is 0.1. Now understand, I will not consider the normal and friction force on surface number 1. Why? Because I have not isolated block A and block B. This normal and friction force is acting between block A and block B. So if A and B are together, then there will be no friction and normal force between A and B. Clear? Now here again I will apply equilibrium equation. From summation of Fy equal to 0, I will get N2 equal to 100 plus 200, means N2 equal to 300 Newton. And then I will apply summation of Fx equal to 0. So I will get P equal to 0.1 into N2 means P equal to 30 Newton. So understand this one. In order to move both the blocks, you need 30 Newton, and in order to move only one block, you need 20 Newton. Now, what are they saying? They are saying maximum force P that you can apply without moving any one of the block. If you apply 20 Newton, more than 20 Newton, block A will start moving. Block B will not move, but block A will start moving. And if you apply more than 30 Newton, block A and block B both will start moving. But they are saying none of the blocks should move. So how much force you can apply without moving either block A or block B? How much maximum force you can apply? The answer will be 20 Newton. If you apply more than 20, if you apply 25, let's say you are applying 25, then block A will start moving. Block B will not move, but block A will start moving. So maximum we can apply 20 Newton. So do you understand this beautiful question where we have to consider both the cases? We have to consider case number 1, that impending sliding is happening on surface 1, and we have to also assume case number 2, that impending sliding is happening on surface number 2. Okay. Now let's move on to the next question. This next question is another very interesting question. Let me tell you, there was a question like this in GATE XC, not ME but XC. Okay, similar question. There was one question like this, similar to this in GATE ME also. Okay. Determine the smallest force P required to start the 30 kg block moving, assuming mu equal to 0.3 and G equal to 10. So understand this question, beta. Here again we have two blocks, one of 20 kg and one of 30 kg. They are saying find the force P required to move the 30 kg block. Why not 20 kg block? Because they have tied a rope between the 20 kg block and this wall. So this 20 kg block is not going to move, right? This 20 kg block is not going to move. So we need to move this 30 kg block only. Okay. Now understand. In order to move this 30 kg block, impending sliding should happen here as well as here, na? In order to move this 30 kg block, impending sliding should happen here as well as here. Okay. So what we are going to do is, we are going to draw the free body diagram of this 30 kg block. Okay. We are going to draw free body diagram of 30 kg block because impending sliding is happening on top as well as on bottom. Then only it will move, na? If sliding is happening here as well as here, then only it is going to move. Okay. So what are the forces acting on 30 kg block? We are applying a force P on 30 kg block. Okay. Now, there will be one force from the top between 20 and 30 kg like this, and there will be one force from the bottom between 30 kg and this surface like this. Let me call this N1. So this will become N2. Okay. There will be weight of this block also 30 kg, na? So 30 into G. G is 10. So it will be 300 Newton. Now, there will be friction force at top as well as bottom. This block we are moving towards left. So friction force will be towards right, like this. What is the value of mu? 0.3. So this will be 0.3 N1. This will be 0.3 N2. I hope this free body diagram is clear to you. This is the free body diagram of the second block. Okay, 30 kg block. Now, in order to solve this free body diagram, how many equilibrium equation do we have? We have two equilibrium equation. We can't apply moment here, na? Because we don't have distances. So we have two equilibrium equations. And how many unknowns do you see here? You see three unknowns. You see N1, you see P, you see N2. So can you solve this free body diagram? No. Then how to solve this problem? In order to solve this problem, you draw another free body diagram, the free body diagram of this 20 kg block, and find the value of N1. Okay. So if I draw the free body diagram of 20 kg block, what will be the forces? Weight of 20 kg block. Okay. Weight of 20 kg block, 20 into G. G is 10. So this is 200 Newton. Now this 20 kg block is connected to this cable. So if you isolate this block from the cable, you will get the tension of the cable T. Now there will be normal force between 20 and 30 kg, na? This N1. So if it is downward here, it will be upward here. And 0.3 N1, if it is towards right here, it will be towards left here. See, this N1 and mu N1 should be acting equal and opposite between block 1 and block 2, 20 kg block and 30 kg block. Let me name them. Okay, let me name them. Let me call it block A, let me call it block B. So this is block A and this is block B. Okay. So now from here I will get N1 equals to 200. Summation of Fy equal to 0. So N1 will be equal to 200 Newton. I don't need to find the value of T. Okay. So N1 I found 200 Newton. So now beta, I will apply equilibrium equation here again. Summation of Fy equal to 0. It will be N2 equal to N1 plus 300, means 200 plus 300. So N2 equal to 500 Newton. So now I can apply summation of Fx equals to 0 and I will get the value of P. So from summation of Fx equals to 0, P will be equal to 0.3 N1 plus 0.3 N2, means 0.3 into 200 plus 0.3 into 500, means 0.3 into 700. It means 210 Newton. So this is the force P required to move the 30 kg block, 210 Newton. I hope this is clear. So in this case, you don't need to consider both cases, case number 1, case number 2. No, because here beta, they have tied this. So this block is not going to move. Only this block can move. So here there are no two cases. But what if this was not there? What if this was not there? Then here also you will use two cases. Okay. Here also you will see two cases, both cases, and you will find the value of P. Minimum of that will be the force required to move this. Right? In one case, block A and B both will move from here, and in one case only B will move. So two things can happen, na? If this is not tied, block B can move alone or block A and B can move together. So in which case you have to apply less force. If block B is moving alone, or if block A and B are moving together. You can consider both cases. Okay. Chalo. Now let's move on to this question. A body of weight 100 Newton is lying on a rough plane inclined at an angle 30 degree with horizontal. It is supported by a force parallel to the plane as shown in figure. Find the minimum and maximum values of P for which equilibrium can exist. A very interesting question, and a very important question. Understand the question. They are saying that we have a body of weight 100 Newton. This is the body. The weight of this body is 100 Newton. It is lying on a rough inclined plane which is at an angle of 30 degree. And we are applying a force P which is parallel to this surface. What can be the maximum and minimum values of P for which the block will be in equilibrium? Now, what do we mean by maximum and minimum value of P? Understand the case, understand the condition. Maximum and minimum value of P. Okay. See, if I apply a force more than a particular value, if I apply a force more than a particular value, this block will start moving upward. What is that particular value? That I will tell you later. But if I apply a force more than a particular value, this block will start moving upward. Let's say that value is 1000 Newton. So if I apply a force more than 1000 Newton, block will start moving upward. And if I apply a force less than a particular value, what is that particular value? Let's say that particular value is 200 Newton. So if I apply a force less than 200 Newton, it will start moving downward. So if I apply a force more than 1000, it will go upward. And if I apply a force less than 200, it will go downward. But if my force is between 200 and 1000, it will neither move downward nor move upward. So this is the range of P, 200 to 1000, for which the block will be in equilibrium. Minimum 200, maximum 1000. So between 200 to 1000 Newton, it will not move. Neither it will go down nor it will go up. But if your force is less than 200, it will go down. And if your force is more than 1000, it will go up. So I hope that you understand the concept of maximum and minimum value of P. Okay. I hope that you understand the concept of minimum and maximum value of P. Right? What is the minimum value of P for which if you apply less than P minimum, it will go down. If you apply more than P maximum, it will go up. Between these two values, it will remain in equilibrium. Now understand this, If this angle of inclination is less than angle of friction, if this angle of inclination is less than angle of friction, then you don't need any force to hold it from falling down. What is the value of phi? Phi is 10 inverse of 0.3. What is the value of phi, beta? Phi is 10 inverse of 0.3, 16.7 degree. So right now the angle of inclination is greater than this. So if I don't apply a force, it will fall down. But what if your angle of inclination is 10 degree? Now answer me. In this particular case, if I ask you, what is the minimum force P for which equilibrium can exist? Then what will be your answer? Answer me this. Angle of inclination is only 10 degree, phi is 16.7 degree. What is the minimum value of P for which this block can be in equilibrium? What will be your answer? What will be your answer? Your answer will be 0. Why 0? Because if the angle of inclination is less than this, it will not fall down. So you don't need any force. You need 0 force from falling this down, na? है ना? You need 0 force to keep this in equilibrium. It will remain in equilibrium automatically, right? Because this angle of inclination is less than this, so it will not fall down. But right now the angle of inclination is more than this phi. So if I don't apply any force here, it will fall down. Why I am telling you this is because there was a question in GATE where the angle of inclination was less than phi. So in that question, P minimum was 0. Okay. So I hope that this concept is clear to you. Right now, P minimum will not be 0 because your angle of inclination is more than phi. So if you don't apply any force, it will fall down. So what I want you to do is draw free body diagram of this block. Consider two cases. One case, this block is just about to fall down. And one case, this block is just about to go up. In both cases, the direction of friction force will be opposite. Okay. So draw the free body diagram of this block. Draw the free body diagram of this block. So the weight of this block is 100 Newton. So I will resolve this into two components. Okay. I told you that whenever the block is on an inclined plane, resolve the forces parallel to the plane and normal to the plane. So this will be 100 cos 30 and this will be 100 sin 30. How do I know? Yesterday I told you that you need to remember this. Whenever you resolve the weight which is parallel, the component which is parallel to the surface will be sine component and this will be the cos component. Okay. Now this is the normal force. Let me call this N1. And we are applying a force P here. Now there will be two cases. There will be two cases. In case 1, you are assuming this is just about to fall down. So this will be P minimum. Okay. And if it is just about to fall down, your friction force will be upward, na? Because I am assuming it is going down. So friction force is going up. 0.3 N1. Okay. And in second case, we will assume it is just about to go up. So this will be P maximum and it is going up, na? So friction force will be down. So do you understand the difference in both cases? In one case, I am assuming it is going up. Sorry, going down. So friction force is up. And in one case, I am assuming it is going up. So friction force is down. Now in both cases, the value of N1 will remain same. N1 will be equal to 100 cos 30. Here also, N1 will be equal to 100 cos 30. But your P will change. Okay. So what will be the P minimum here, beta? Here, P minimum plus 0.3 N1 will be equal to 100 sin 20. Na? It is in equilibrium. It is not going down. I am assuming it is just about to go down. So it is in equilibrium. So P minimum plus 0.3 N1 should be 100 sin 30. So from here, I will get the value of P minimum. So what is P minimum, beta? 100 sine 30 minus 0.3 into 100 cos 30. So I am getting 24.02 Newton. P minimum is 24.02 Newton. In second case, P maximum will be equal to 100 sine 30 plus 0.3 and 1. Okay. So P maximum is 75.98 Newton. Means almost 76 Newton. This is almost 24 Newton, 76 Newton. So if you apply a force less than 24 Newton, it will fall down. And if you apply a force more than 76 Newton, it will go up. Okay. But between 24 to 76, it will neither go down nor go up. It will remain in equilibrium. Okay. Between 24 to 76, if P, we have three cases. Okay. If P is between 24 to 76, second case, if P is less than 24, and third case, if P is greater than 76. Okay, so what is happening in all three cases? In first case, block is in equilibrium. Second case, block goes down, block slides down. Third case, block slides up. Okay. So if P is between 24 to 76, block will be in equilibrium. It will neither go down nor go up. If P is less than 24, block slides down. If P is greater than 76, block goes up. I hope it is more than clear to you. And if in the same question, angle of inclination is less than phi, then this P minimum will become 0. Then it is not going to go down. Okay. So P minimum will become 0 Newton. Okay. Chalo. So let's move on to the next question. Now this next question is very interesting because here we have a ladder. The 15 feet ladder has a uniform weight of 500 Newton and rests against the smooth wall at B. We have a ladder, you can see. Uniform ladder means the weight will be acting at the center of the ladder. Okay. It is resting against a smooth wall. So this ladder is in a very rich person's house who has done a very costly paint on the walls. So it is very smooth. So coefficient of friction on the wall is 0. It is very smooth. Okay. But you can't do that to the floor. Otherwise, beta, you will fall down. Na? You need friction on the floor. So there is friction on the floor, which is 0.4. So on the wall, friction is 0. On the floor, friction is 0.4. Now we need to find the minimum angle so that the ladder does not slip. See, what is going to happen is, if the ladder is standing, it is not going to slip. Okay. Now slowly, if I start decreasing this angle, what will happen is there will be a point when the ladder will not be in equilibrium, it will fall down. If it is like this, it will not fall down. But if I slowly decrease the angle, there will be an angle after which it will fall down. So we need to find that angle after which it will fall down. So how we are going to find that angle? We will assume that the ladder is just about to slip. Assume that the ladder is just about to slip, and in that condition Draw the FBD of the ladder. Assume that the ladder is just about to slip. So if the ladder is just about to slip, then the friction force at A will be the limiting friction. Okay. So here the weight of the ladder is 500 Newton. It will be acting at the center 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7. This is the center. This is the center. Okay. Not this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So 1, 2, 3, 4, 5, 6, 7. Here will be the center. This will be the center. Okay. What is the weight of the ladder? Weight of the ladder is 500. Now there will be a normal force at A and a normal force at B. Normal to the surface. Okay, so here the surface is horizontal, so normal force vertical. Here the surface is vertical, normal force was horizontal. Now we are assuming that the ladder is just about to slip. So if it slips, then this A will move towards left. If it slips, the A will move towards left. So the friction force will be acting towards right. Friction force will be acting towards right. So this will be the friction force, right? 0.4 NA. So now we need to find the value of angle theta. So how are we going to find the value of angle theta? Understand this. In order to find theta, we need to take moment at a certain point. Where we will take moment? Obviously we will take moment at A, because there are two forces acting at A, na? So if I take moment at A, the moment of both these forces will become 0. But in order to take moment at A, I need to first know the value of NB. How we will find the value of NB, beta? From summation of Fy equal to 0, Na is equal to 500 Newton. So from summation of Fx equal to 0, NB will be 0.4 Na, means 0.4 into 500, 200 Newton. So now I have the value of NB. So I am going to take moment at A. If I take moment at A, moment of 0.4 Na and Na both are gone. I will get the moment of this NB, which is anti-clockwise, and I will get the moment of this 500 Newton, which is clockwise. So what will be the moment of NB? What is this distance? What is this distance? What is this distance? This distance will be equal to the length of the ladder L cos theta, sorry, L sin theta. है ना? So this is L cos theta. Okay. So moment of NB will be equal to 200 Newton into L sin theta. Okay. And this will be anti-clockwise, equal to moment of 500 Newton, which is clockwise. So moment of 500 Newton will be 500 multiplied by this distance. Now what will be this distance, beta? obviously this will be half of this distance na. This is L cos theta, so this will be L by 2 cos theta, है ना. अरे C is the center na, so if this is L cos theta, then from center the distance will be L by 2 cos theta, so it will be 500 into L by 2 cos theta. So L and L will be cancelled. This will be 200 sin theta equal to 250 cos theta. So it will become 10 theta, sin theta by cos theta equal to 10 theta equal to 250 by 200. So theta will be 10 inverse of 250 by 200. So tell me what is the angle theta? 10 inverse of 250 by 200. I am getting 51.34 degrees. 51.34 degrees. So this is the angle theta at which the ladder is on the verge of slipping. If I decrease the angle theta even slightly, the ladder will start falling. So this is the minimum theta till which it will not slip. If I reduce the angle theta further even slightly, it will start slipping. Okay. So I hope that you will be able to solve this ladder type questions also. Okay. Chalo. So now I will give you an assignment question to solve. This is another question of a ladder. Which is an assignment for you. Okay. We will discuss the answer to this question in the next class. Thank you so much for joining. I will see you in the next class. Till then, bye-bye. Take care. Good night.